That's why you asked if I started the recording. Okay, so last time we had talked about, well, we got our file transferring from one point to another point over a socket connection. But now we want to create this model where we have our one server up here, and we can have multiple clients where each client has a portion of this file that they want to share. Okay, and we want this guy to be able to get, well, here's our new guy from last time. So this client right here, he wants to get this file. But he wants to get this file in a relatively efficient manner. And we talked a little bit last time about, maybe we don't do 1 byte at a time or something like that. But in our example here, we're going to do 1 byte at a time just to keep things as granular as possible. So this guy essentially has an array he needs to fill up. Okay, an array of bytes he needs to fill up. At the end of class last time, we were talking a little bit about if we start getting into, 8, 9 gigabyte files, or I think maybe you mentioned a 50 gigabyte file, more than even Haxton has for RAM. Something that won't fit in RAM when we start. Oh, Alex, how's the diarrhea?
And vomiting. And vomiting.
And vomiting.
And fever.
No, and vomited.
Oh. Did you get pictures?
He did. He sent me some stuff.
Oh.
That's all I'll say. Alex replied back when I was talking to him after class. He goes, so why do you want pictures so you can make fun of me? He says, no, we didn't need pictures for that. You are feeling better though, Alex?
Yeah.
All right, good. You probably caught it from her.
Oh my God.
Well, not her. Her. She had a different kind of sickness. She had the... All right, now that I've offended everybody.
Comment against the Amish yet?
Not yet, but that probably covers it. The Amish don't even have modern plumbing, so it's even a bigger issue for them.
Or toilet paper.
That's right. They just use their beards. All right, everybody shut up. Let's start with we gotta focus. Focus. Next thing we're gonna be doing is we're gonna be misspelling Brazil again.
What does Amish do then? He doesn't have a beard.
He did.
Yeah. I know, but what does he do now?
He doesn't. That's why you're sitting there and he's sitting over there.
Air dry?
Okay.
Also, I thought you were going to send out teams.
Yeah.
After class, you want to walk into my office, you will see that the teams are almost being built. I have to balance them. I need to make sure that you and you are not on the same team.
Why not? I won't go.
Huh?
It's too late. We're already funded. Don't screw this up.
Shut up! Shut up or we're having a quiz. We have to focus. Okay. So in any case, we want these guys. So this guy just came in. He's going to talk to the server, and the server is going to know about the files that he's currently sharing. Now, for our initial model, the server really knows how to share one file. That's the one file this original guy seeded. So in our initial model, the first dude who comes in and says he's sharing something, we're going to say it's a requirement. Server gets started. This guy comes in, shares the file with the server. Okay? But he's going to let the server know that I have a file. Okay? That I have a file, and this file has so many bits, or so many bytes in it, rather. Okay? So the server's going to keep track of that information. So we're going to keep track of file name and num bytes. Okay? So when anybody else goes and connects, for the way we're going to deal with this time, or for us, since we're not going to create a format for like a torrent file, when a client connects, they're going to be able to get a list of available files. Okay, in our case, there's only one file. Here's the file you can download, and this is how big it is. Okay, so each client would then maybe issue a request to get that file. Okay, and then from there, the server is going to get things started. So we're going to say that these two guys are already getting that file. And this guy now comes in and he says, okay, he talks to the server says, here's the file that's available. He says, okay, I want to get that file. And then from there, the server is going to give this guy the information that he needs in order to get the file from these other people. Okay? So our first step, and I think we were working on this last time, is we need to make it so that our server gets this information and now accepts requests for what file is available. Currently, our server gets a share, and then he's going to start listening for other connections. All right, so let's go back over and look at our code. All right, so we have client, server, here's client communication. Okay, so initially, when the client starts connecting, we're talking directly to the client here, so this is not dealing with the internet at all yet. We're going to locally capture the file after they choose which file, and then we're going to set ourselves up to prepare for a byte request. But at this point, we haven't let the server know, correct? No, we do, right here. So let the server know about the file we're going to send. So here's the file name. And then here's the number of bytes available. Okay, and again, we're doing this kind of not in a protocol, but moving towards a protocol. All right, so we let the server know about it. Then we locally cache our file. And this only works, this is what we were talking about right at the end of class last time. This only works if we have a file that is reasonable in size that will fit in memory. Right now, we're dealing with JPEGs. That'll work, okay, to solve the real problem we're trying to solve. All right, then we're going to start waiting for stuff, but that hasn't happened yet. Okay, so I'm actually going to comment this out for right now. So this guy isn't actually waiting. Actually, I'm going to do this. Nah, I'm just going to delete it. We're going to write it a different way. It's fine, not important. So this guy's in position now. This is our original client. So that's this guy right here who said he's going to share stuff. So he set up. Now, all these other guys are used in the same code base as that same client. Something we took out last time was, what do you want to do? Are you sharing or are you receiving? That make sense? So right off the bat, the very top of our file, we're building in all of our communication stuff. Okay? But before we show them the files, we need to go ahead and ask them what they want to do. Do you want to share or do you want to get? Okay? So we're going to do this. We're going to ask the question. We're going to say system.out.println. What do you want to do? Share or get? And we'll do this as a print. And then we'll read in that answer. String answer is equal to terminal input, so we're reading it in from the local client. Next line. Okay. Now, we'll ask the question. If answer dot equals ignore case, we'll say, share do share stuff. Else do get stuff. All right. Now, instead of just throwing all the share stuff inside of this if statement, we're going to write a private function for sharing. So private void share file. What happened?
I shut my computer down because it was annoying me.
Oh. And we're going to take all the share stuff out of there and put it inside of share file. Okay. Now, notice that we have several objects that are required that we built inside the other guy. So server output, terminal input, these are all required things. So what we're going to do is we're going to actually make these private global variables inside of client communication. So we'll take that guy. Do that. We will take this guy, terminal input. Do that. We'll take our server output. I'll make it private. Do that. Okay. Now, all of these guys really should be initialized inside the constructor, right? Notice that we're really trying to slim down what start communication does. So we're going to take all of these pieces here, cut them, and we're going to paste them inside of the constructor. Variables are already defined, so I don't use, and I like to use the this dot thing, so just deal.
Command I.
All right. Now, all of these guys potentially throw an exception, right? So we'll keep things fairly compartmental. No, we won't. We're lazy. All right, so we're going to throw an exception. All right, so now Client Communication Protocols Constructor builds all of our things for reading and writing to and from the socket, as well as writing to the, reading in from the console. Writing to the console is built in, system.out.println. Okay, so we have all the tools that we need later on. So if we go down here, we notice that start communication does what? It just asks, what do you want to do? You want to share or get? We'll read in the answer. If we said share, call the share stuff. Otherwise, call the get stuff. Here's our share stuff up here. So this is going to be called this.share file. So we'll call that. Otherwise, we'll probably have a private void get file. Let's go ahead and write it there and leave it empty. That way inside here we can say this dot get file. Okay. So what does it mean to share the file? Well, we're going to show them our current directory, ask them which file they want to share, read in the answer, tell them which file they chose to share. That's just spitting it back out. Read in the file. Okay. This guy also throws an exception. What do we do when we throw an exception? Now, just out of curiosity to throw it out there, does everybody understand what I'm doing here when I say throws exception? Now, I want everybody to, I jokingly just put it up there, but do we understand that this probably is not real great programming practice? I'm avoiding throwing all this stuff inside of a try-catch. Trying to do a bunch of stuff, catching the exception E and dealing with it. Okay? By just passing the buck here, I'm saying let it be somebody else's problem. And then I pass that buck throughout the entire application, so ultimately it becomes a Java virtual machines problem. Really what I'm doing is I'm completely avoiding using exceptions at all, and if my program crashes, so be it. Okay, I'm not handling exceptions. I'm not allowing my program to crash gracefully. So this would be fairly bad programming practice, but it allows us to focus on the networking parts of things rather than error checking everything. Make sense to everybody? All right, so I don't want you to go and get a job at some point and just say, well, our professor told me to just throw all exceptions. In fact, he even wrote comments that just say, yeah, right. There's all over the place. Okay, so I would say only throw an exception if you know what you're doing. Generally speaking, you should deal with the exceptions so you can handle them gracefully inside the program. All right, so we'll read in what file. We'll print out the file that they chose. We'll read that file into our local dealie. That's our file input stream. We're going to then write to the server the name of the file and the size of the file. Those two pieces of information. Okay, not the file bytes itself, just the name and the size. Okay, and then here is where we locally buffer the file, so that this guy knows about the file. Now the reality is that we will probably move this array globally as well. For right now, we'll just leave it there. This guy's locally buffering it. We'll have to decide how does a sharing client now deal, because a sharing client is probably going to then turn into a getting client for another file, at least potentially. But for right now, we're keeping the model simple. So let's jump over to the server side now. Save this. The client, here's the server. So we have our connected client. Is that what, yeah, right? Oh, there we go.
Yeah, the one time you use a try.
Oh. It's beneath me. Too good for try catches. My code never throws exceptions. Unless you guys are doing denial of service attacks. Yeah, when else could you have a class where your students are doing a denial of service attack on your class program during class? It's just terrible. It's almost as bad as you guys trying to steal bitcoins last year during class. my public API.
What?
Huh?
Nobody actually stole anything, but
Definitely could have.
Yeah, I had
It was just-
we were working with the Coinbase, not Coinbase, yeah, CEX. We're working with CEX's API.
Not
and
really.
And I had a read-write public key, or I had my private key in the code. So any of them could have written stuff and deleted stuff from my account and sold stuff and bought stuff.
It was
Yeah,
up on
well,
YouTube
we
for an
could buy
entire
up
week
to
or something.
$5 grand. What was it?
Huh?
Buy up to $5 grand.
50 grand.
50 grand. 50 grand with Bitcoin.
Yeah.
You
Send them
didn't?
to a random account that we had. Nobody would have known who.
and you didn't because
All right. Because he's ethical and at a Christian university. I did it on purpose because we were testing ethical computing.
I don't know. This is the kid who has his favorite bite.
Pretty sketchy. All right. So over here on the server side, the server is going to get the name of the file from the client. It will then get the size of the file from the client. All right. And so again, remember what we did is a few minutes ago. We made this decision I just said this is how we're going to make this work. We start the server first, then the one client who's sharing the file talks to the server. None of these other guys are allowed to get involved until we've kind of primed the pump, if you will, with these two things. Okay, so the server, before any of these guys connect, the server knows about the name of a file it's going to share and the number of bytes that are in the file. He doesn't know about the actual bytes, just how many of them there are. Okay? So then I think we have this connected client thing where we have number of bytes. So this is what we're writing at the end. I think I said something along the lines of we have opportunity to use a Boolean array. Not something you get to do every day. So, this is whether we've received the bytes, and then we're going to also have to pass the bytes through at some point. Okay, but we'll do that as we're connecting up this side of things, as these guys come in and connect. That is the guys who are coming in to get. Okay, so server, response thread, it will read in those things. It will then set this client init bytes to size. Here's init bytes, and it just sets all of those guys equal to true. Because the guy who's sharing has all the bytes by default, right? So we're letting the server keep track of this particular client, and he has bytes for the one file that our server knows how to share. We're not supporting multiple files at this point. Okay, then what does display bytes do? This just displays all the trues or falses, or just trues in this case. So that was more just for testing, I'm sure. Yeah, display bytes, we'll take that out. We don't need that right now. Okay, then we had this stuff about to receive and stuff like that, but this guy's not doing that anymore. Okay, he's not receiving bytes or anything like that. In fact, we'll just get rid of that. Okay, so here's our server. His response thread has created these things, and now he has this file. All he knows about right now is the name of the file and the size of the file. Okay? In this run method, this guy needs to know whether or not the currently connected client is a sharing client or a receiving client, right? A getting client. So back over here on the client side, we asked the client down here, what do you want to do, share or get? If you chose share, we're going to call our share file. The very first thing we should do inside of share file is we should write out to the server this dot server output dot println. We'll say share. We're going to let the server know that we're sharing. Similarly, if we're getting, inside the get file, the very first thing we'll do is we're going to let the server know that we're getting. Okay? Every client's going to come through this client communication protocol, and they're going to make a decision. Am I sharing or am I getting? And if they're sharing, they're going to do the share file. If they're getting, they're going to do the get file. They now need to notify the server so the server knows what mode to go into. Okay? So now, back in response thread, before we wait for the client to tell us the name of the file, we first need to ask the question, is the client sharing or getting? So we'll have a variable called client mode, and this guy will be this dot the client dot get message. That's going to read in either share or get. Again, we're assuming that not only am I assuming my code never throws exceptions, we're also assuming that the end users never misspell things and always use the program absolutely correctly and all that stuff. So it's it's a balancing act here in terms of how this is going to work. So we can ask if client mode dot equals share. Then we'll do share stuff. Else must be get. Do get stuff. Okay? Share stuff means get the file name, get the size, and then initialize the currently connected client to set him up so that the server knows that he has all the bytes because he's the one who sourced it. Okay, he already has all the bytes. We're probably going to need to move these guys into a more global type setup, but for now we'll leave them there. For a get, and so just for right now, for testing this, let's just do a system.out.println sharing mode. And getting mode. All right, so every single client that connects, if we go back out here to our driver for our server, every client that connects, we're waiting, we accept the connection, we create our connected client, we add it to our list of clients, we create a response thread, and we tell our response thread to start. What does this guy do? Response thread, right off the bat, asks, well, doesn't even ask, just receives from the client its mode, share or get. That makes sense? So if we're adding that to our picture here, this guy's in share mode. And in our model here that we're working towards,
Shouldn't the arrow be the other direction?
probably. Just pretend like it's not. I even debated not even putting an arrow. Well, actually, I think the arrow. I think this is reasonable for the arrow, because this guy's letting him know I'm sharing. I'm letting you know I'm getting. I'm letting you know I'm getting. So this is right. You're wrong. All right, so all these clients are going to be in get mode. This one client's in share mode. Now remember, down the line, they're all going to be sharing bytes. But this is really talking about, is this the source of the file, or is this the are these people who want the file? Okay. Read in the mode. If we're in share mode, do this stuff. If we're in get mode, do something else. So right now the server's just going to print out sharing mode or getting mode. All right. So we're going to go ahead and test this just to make sure that we can get things into different modes. And remember, the order of operation is going to be important for us. So we're going to first start up the server, then start up our one client that's going to share. Then we'll start up a second client that wants to get, just to show that our logic flow through is working. So I'm on Kristen's iPhone here, and I'm on Android E3.
It's actually the same as last class.
Is it? Well, just hasn't. Oh, because I haven't updated the terminal. Michael's MacBook Pro.
I'm on Kristen's iPhone. I'm on Kristen's iPhone.
She's cheating on me. Michael's MacBook Pro, is that in here? No. Wait, hold on. That might be my machine.
I was gonna say.
The one time it's connected.
Wait, who is that? It can't be my machine. I'm guessing it must be. So hold on, I need to get the present working directory for my client. So we're going to call this guy share client. And we're going to call this guy get client. Well, that's funny. It can't get to the path because the path I copied isn't just very nice. All right, so show in System Explorer. Let me see, that formats it nicely. All right, then we'll move our clients together. So this is going to be our share client, our get client, and our server. So first thing, we need to go ahead and recompile the servers. I think we made a couple of changes. But that's not going to work. That'll work. All right, then we'll start the server up. Okay, server's waiting. Next step is we need to go to our share client. So I need to compile the client. What do you want to do? Share or get? I'm going to share with this guy. Which file do I want to share? I'm going to share my Rickroll one. Okay. This said you chose to share the file. It's now locally buffered. When I go back to the server should show share mode. There's sharing mode. Okay. Now I'll go and start my get client. I don't need to recompile it because it's the exact same client code base. So I'll do Java driver. Do you want to share or get? I'll say get. And that's all this guy does right now. But on the server side, we should have seen that somebody's in getting mode. There's our getting mode. Make sense? So we kind of have our logic flowing through right here for sharing bits. Okay, so that puts us in this position right here. We support multiple clients all connecting in getting mode. Now, when a client wants to get, we can let them know, if we'd like, we can give them a list of files they can get, but that doesn't make sense in our model because there's only one file. Okay, so we're not going to waste time giving them a list and having them choose. We're going to send them the name of the file they're going to get. And we will also tell them how large that file is. Okay, so the server is now going to have to communicate to each client the details about that file. Make sense? So we'll go ahead and add that. So this is on the server side. Response thread. If we're in getting mode, we need to share with the client the details about this file. Okay, now this gets a little bit interesting. So this becomes kind of a programming architecture issue. So I need to write out to the client, that is this dot the client dot what do I call it? Send message. There we go. Send message. I need to send him the name of the file. Send the client the name of the file. Now, as of right now, file name is stored up here. But we need to keep in mind where we are right now. We are inside of a particular instance of response thread. Okay, particular instance of response thread. Which means that if we're in this instance of response thread, the one that we've chosen to be in getting mode, that's a different instance than the response thread that knows about the file name. So we certainly can't have the file name stored in here, because it's out of scope for this guy. But similarly, even if it was in scope, so even if I had it stored up here, string the file name and int the size. So even if I had it global inside the run method and set them inside of the share code, if I were inside of this else and I wanted to print out the file name, well, first of all, it's going to yell at me and say it might be null. So I'll just initialize them to some value. Okay. I'm promising you the file name will not have anything in it because the file name actually got filled by a different instance of response thread. Make sense? So I need to make this somewhat more global. So what we're going to do, just for this model, is we'll come up top here. I'm going to actually steal both of these variables. we're going to make them static and private. Okay, so we'll have a private static, the file name, private static, the size. That means this variable and this variable only exist one time, and they're owned by the response thread class. Now again, all of this relies on us starting things up in the right order. Generally speaking, I would say this isn't great programming practice either, but we're writing a very specific version of this server to send one byte at a time. So let's kind of focus on our details. Okay, so now when I set the file name, I'm setting response thread dot the file name and response thread dot the size. These are global variables that only exist once that are owned by the response thread class. Now when I'm down here, I know I'm only in getting mode if there's already been a guy in sharing mode. We're not policing that, but that's our rules we've set up. Right? Server starts, share mode client connects, now we can accept get mode clients. So that means I can send to the client the file name, and I can then also send to the client the size. Oh, this needs to be as a string. There. Get send message requires a string, so I just turn the size into a string. Okay, so we have those two pieces of information. These are getting sent to the client in get mode. So go back over to the client side. Here's our client communication protocol. Here I am in get file. Next thing I'm going to get is I'm going to get the file name. And this is going to be this dot server input dot next line, because we are reading in a string, not a byte. It's reading in a string, so next line is sufficient. This is using our scanner. Similarly, we'll say int the file size is equal to integer dot parseInt this dot server input dot next line. I'll read in the file name, I'll read in the file size, system.out.println, ready to receive the file name, concatenate with the file size, concatenated with that.
Add a plus.
Oh, thank you. Just testing you.
Did I win this time?
Nope. You didn't even tell the class about me scaring you. So I came out of the bathroom before him, and I said, I'll see you in class. So then he was in there for like another, I don't know, 15 seconds or something. I was standing right outside the door, and as soon as he came around the corner, I like lunged at him and stomped down. He screamed like it was hilarious. And then I said, aren't you glad you went to the bathroom? Because that would have been funny. Then you would have been off the hook, Alex. All right, so we'll tell the server we're going to get. We'll receive the file name, receive the file size, and then spit out on the client side that we're ready to receive whatever the name of the file is and the size that that file is. Proving that the server received that we're in get mode, the server then let us know about what it has to share with us. Okay? So all we're doing here is taking a couple little steps in each direction, kind of letting this organically grow by handling the client side communication and the server side communication. Kind of make sense? So let's test this. Go back in here. Let's kill off our server, and that should kill off all the clients. Okay. Go ahead and compile the server, run the server, go to our share client, compile that, run that. I'm going to be a sharing client. I'm going to share that file, locally buffered. It's share. Who's Kristen's iPhone? Oh, that's the same one as before.
Yeah.
Wow, I'm very confused today, aren't I?
Yeah.
I shouldn't be writing client-server programs. It seems highly dangerous. Abe, can you keep an eye on me? Am I doing this right? This is this is going well. All right, so.
You may have made a mistake assigning teams for.
I believe so.
All right, so you don't want to be on my team,
Was he
Am
on
I
your
in your
team?
team?
huh?
Am I in your team?
No. I don't want you on my team. Question is, do you want me on your team? What was I talking about? No, we don't have to recompile it for the get client. We'll just rerun it. I'm going to get, so this guy's going to say I'm in get mode. Server receives that, sends back the name of the file and the size of the file. This guy then spits it out, proving that he received it. Ready to receive, clone rickrolled links header.jpg of this size. Cool? All right, so we got that communication going back and forth. Now the client knows how big of an array he needs to create for receiving this file. Okay, now keep in mind, this kind of goes back to what he was saying last class about, well, can we really trust this number? Up to this point, it seems like we can trust this number, but this kind of falls into that same category of no exception handling. So we'll kind of deal with that a little bit after we have the model working. But the important thing for us here is that we can actually see kind of how a communication protocol like BitTorrent might work.
Just add 10 to it.
Huh?
So just add 10 to that number. We're covered.
just read extra empty bytes? No, I think we're fine. All right, so client received this, proved that he received this by spitting it out to the screen. So now the client can go ahead and create a byte array of that size in order to fill up. Okay, and the client will know that that byte array is what? He'll know that that byte array is its source. And once it's completely filled, then he knows that he can write it out to disk and he has a file. Correct? But now we need to remember on the server side. Where am I at? I'm lost. Response thread. So here's where we're writing out to the server. Notice that for a sharing client, we let the server know that we let the client, which is a connected client object, know to initialize the bytes for our sharing guy to the size, and it went ahead and filled it up with a bunch of trues. Right? That's this guy right here, init bytes size. We're going to modify this a little bit to take in a Boolean B. Instead of hard coding it to true, we'll hard code it to B. Well, not hard code it, we'll make it whatever B is. Okay, so that's for initting bytes. So now what we'll do is back here on the response thread, when the sharing client initializes bytes, he wants to initialize it to a bunch of trues. He has all the bytes. When the getting client initializes bytes, he's going to initialize it to false. He has none of the bytes currently. That make sense? Now, this is again the server. So now we're going to wait for client requests for receiving. That's not how you spell it. I before E. No, that's right. I before E except yeah. Isn't that the thing? I before E except after C? See, they even said that back in the Stone Age.
There's exceptions to that.
Huh?
There's exceptions.
Well, actually, I'm the Bronze Age. Her dad's Stone Age.
What does that make us?
I don't know, you guys. You don't think you use weapons? We're laser tag age here, right? All right. So client, wait for client request for receiving and sending. Okay, this is going to be a two-way type thing. All right. We're going to do more of a share model when we write this, but we're just kind of setting it up. All right. So wait for client's request for receiving and for sending. We're probably going to actually have to spawn off a second thread. So the client will have a sending thread and it'll have a receiving thread. So both of these things are going at once so they don't block each other. All right. So that's what's going to happen here. Now, if you're the client who's the sharing guy, you're also going to be waiting for the client request for receiving and sending. You'll be doing the same stuff. Okay? Realistically, you're probably not going to be doing a whole lot of requests for receiving bytes, but certainly you're going to be sending some stuff. Okay? So what we'll have to do next time is we need to finish up this model. So if somebody can just write down a note that we are in the middle of our server response thread for whether we are share or get to actually handle the requests for bytes. Because we have everything written up to this point. Now these guys actually want to start receiving stuff. So this guy is going to say something like, I need byte 0, I need byte 1, I need byte 2, I need byte 3, so on and so forth. And the server is going to decide who has those bytes and send the request so those things get connected. Okay, so the server just keeps receiving requests and hooking them up with the people who have it. Make sense? Okay, so we'll finish writing that on Wednesday. So no class Friday, no class Monday, right? Okay, so for those, should I give you a homework over? For those of you who are traveling, travel safely. Have a good Easter. Learn how to spell Brazil. Get better. All right, I'll see everybody on Wednesday.
I sent you that.